When we are thinking about y equals the absolute value of x, there's kind of two places where we can multiply by a negative. We can multiply by a negative in the front where we call the letter a, or we can multiply by the negative on the inside, right on the variable. Now, it is really hard to see the changes that happen when we use absolute value for this. So we're going to switch to y equals the square root of x as our parent graph to do these two discoveries. But I think it's because you'll be able to see them a little faster. So let's go back to our new parent graph, which is square root. Remember, it's a parabola that's been tipped on its side and the bottom's chopped off. Looks like this kind of arching thing going off to the right. And what I'm going to do in this graph is that I am going to put a negative sign on the front. And it's going to happen really quickly what changes. So be ready for that difference. But take a minute and tell me, okay, what changes when I put that negative on the front of this graph? And what happens? Some people say, oh, it flipped upside down. And yes, that is a very easy way to say that. It flipped upside down. We're going to say it in a little more fancy way. What is the axis that is this horizontal axis that it flipped around? We say it rotated around the x-axis. That's going to be our fancy way of saying what happened. So when you put a negative on the front of an equation where the a is, it is going to rotate around the x-axis. I will also accept, so you need to recognize that when you see rotate around the x-axis, oh, that's that upside down. It's flipping upside down, right? I will also say accept a vertical flip because I believe in a vernacular way that is saying what it does. So you need to be ready for both. I will accept both. You can call it a vertical flip, just whoop, flipped upside down, or you can say rotate around the x-axis. Both will be acceptable and both will be mentioned when we're doing these things. So let's look at, okay, so let's go back to our original function. And this time, instead of putting the negative in the front, let's put the negative in front of the x on the inside. So if you kind of remember, adding and subtracting outside made it go up and down. Putting a negative on the outside made it flip upside down in a vertical manner. So what do you think is going to happen when we put a negative on the inside? Well, inside adding made it go left and right, but backwards and stupid. And when we put a negative on this inside on this x, what's going to happen? It rotated horizontally. Horizontal things are what happen from the inside. Now, the fancy way of saying this is what is this vertical axis that it kind of spun around? That is the y-axis. So our fancy way of saying this is that a negative on the x sitting on that x variable is going to cause this thing to rotate around the y-axis. But Mrs. Hoffman will also accept that this is a horizontal flip or a horizontal rotation, vertically versus horizontally. If you like to say it that way, that's fine. Again, either set of languages work, but we need to understand what does the negative do. Outside, it flips it vertically. Inside, it rotates it horizontally.